In this video, I'll be working through the question you can see on the screen from the Cambridge A-Level Maths Paper 1. Specifically, it's Paper 1-1 from the winter exams in 2023. If you're looking for a different question from this paper, there should be a link to a playlist with all the questions below this video. I'm doing this on a whiteboard. Hopefully it'll be like you're used to your teacher doing. And if you do find this or any of my other videos useful, I'd greatly appreciate it if you like, subscribe, or even share it with a friend that's doing the exam this year or next. Question 2 is a particularly tricky question, so let's take our time to go through it. They give us two equations here. The first one's an equation of a line, has just an x here, x to the power 1. So this is what a line looks like. We just don't know what c is. And the equation 2 is, it's actually a quadratic. They say just a curve. It's quadratic, there's an x squared, there's an x, there's a number. We just don't know what c is. And what's interesting is they have a c in common. If you change the number in one of them, you change it in the other. So, well, let me just draw something out. I can't really draw this, because the line could look like anything. Actually, we know it hits the y-axis at 3, but it could look like anything. Let me just draw one of them in. Maybe it looks like that. Well, so then the curve, well, if I knew this slope, I'd know this curve. I don't know what it looks like, I'll just make something up. It looks like that. Now what makes this interesting is, if I move the line, the curve moves as well. So if you change the number c, and you can probably do this, there's loads of computer simulation websites. Put both of these in, put c as a variable, change c, and watch how all this changes. Now they give you three questions, three options of what happens. They ask you, does the line and curve intersect only for certain values of c? So maybe when c is one number, it looks like this, and you change c and they intersect, but eventually it would become something like this, and they don't intersect. Is that what happens? Do they sometimes intersect, sometimes not when you change c? B asks, the line and the curve intersect for all values of c. So if you change c and you get different, both of these move, stretch, go up and down, but no matter what you do, they always intersect. That would be B. And then the last option, C, well, I guess this picture will do. C, the line and the curve do not intersect for any value of c. So if I change c, no matter how I change it, they never intersect each other. That's what they're asking, and it's not quite clear how to do that. So how do you start this question? Well, they're talking about intersecting. A line and a curve intersecting. And we will be asked this, you will be asked this in your exam. You'll be given a line, you'll be given a curve, and you'll be asked something about their intersecting. So let's just go ahead and have these intersect. Put them equal to each other. There's already a y. So put these both equal to each other. So we can just write that 2cx plus 3 is equal to cx squared plus 3x minus c. And let's try and solve this. Just like we would normally if we knew c. We'd get quadratic out. There's x squares here. Let's rearrange it so we have a quadratic. We'll leave this x squared, and let's move this guy over here. So we'd have 3x minus 2cx. Combine them like this. I'm sorry if I'm going a little quick there. Yeah, I'm just moving this guy over the equals, and 3 minus that. 3 minus that. That's where I got that. And again here we'd have minus c minus 3. And all that equals 0. Or I'll just write the equals over here. This is a quadratic. Now we can't really go any further because we don't know what c is. We can't solve this. But remember, they're talking about, does it intersect, does it not? We should recognize that sort of language, especially with quadratic equations. Because if you draw out a quadratic equation, usually they hit, but sometimes they look like that. They never intersect. And this is the solution to these two. So you've reduced this question, let's use this one here. This into something that looks like this. If these don't match, if these don't intersect, then this doesn't intersect. If this intersects, the reduced down quadratic will intersect. So at this point, what you need to do is you need to find out, does this intersect sometimes, never, or all the time? And what you should be thinking is quadratic intersect. You should be thinking b squared minus 4ac. Is it bigger than 0? It intersects. Is it equal to 0? It intersects once. Or is it less than 0? It doesn't intersect. Let's look at that. Here's b, here's a, and here's c. Let's write it out then. B squared is 3 minus 2c squared, and minus 4 times a times c. This is minus c minus 3. Minus will multiply in and clean this up. So yeah, let's clean this up. Where are all the c squares coming from? From here. This is 4c squared. Here's another c squared. Minus 4 times minus 4c by minus c. That's plus 4c squared. Where are all the just c's coming from? This will be 3 times 2 is 6, or minus 6. And we get 2 times 3 for another minus 6. So we get minus 12c. And over here we'll get minus by minus plus 4 by 3, 12, and c. And let's see, we got any numbers? No numbers from here. Over here we got 3 squared will give us a number. That'll be 9. That's what let's clean that up. We get 8c squared. These cancel, plus 9. So now the question reduces down to this. If this is bigger than 0, if it's bigger than 0 or less than 0, basically. That's what the question reduces down to. And you would get a lot of marks for getting here. But at this point, you do need to understand it quite well. You need to understand that this number is always bigger than 0. Have a think about it. What number could you put in for c that would make this whole thing less than 0? C squared will always be bigger than 0. If it's minus 2, it'll become 4. If it's plus 2, it'll become 4. No matter what number you put in here, a real number, you will get a positive answer. 8, a positive number times a positive number, that'll be positive. Add 9 onto it, it'll still be positive. This guy here, and I'd write something like this, always bigger than 0. That means no matter what number c is, this will have a real root. If this has a real root, it means they must have intersected. They must have intersected, no matter what c is. So the correct answer would be B. The line and the curve intersect for all values of c. So go ahead and put B down somewhere. That's a hard question. Like, honestly, that is a really hard question, and I would not be surprised if lots of people just give up on it. Now, what I want you to do in an exam, if you get something like this, you don't know how to do it, it's a hard question. Even my teacher told me it was a hard question. That doesn't mean you can't get marks on it. You see this question, you give you a curve and a line, and they say intersect. They say it 3 times. Well, you should put them together. Once you get this, you should see a quadratic. You should write out the quadratic. Sorry, get here. You should write out a quadratic. At that point, maybe you get more marks. You should be thinking, is there real roots or not real roots? Is there a solution? Is there not a solution? If you thought about this, that'd get you another mark. That should get you all the way down to here. And then the last thing is to notice that this is always positive, and that gets you to the final mark answering the question. Now, if you do have any questions about that, put them in the comments. I'll do my best to answer. Like I said, it was a hard but I think interesting question. Thanks for watching and have a good day.